In their first 4 years, children have learned to express themselves. It's a tremendous achievement. The young artist dabbles with language. Playing at being a grown-up, learning to use grown-up words and phrases, spinning whole sentences, telling stories, involves weaving through the intricacies of grammar and syntax. How they manage it is cloaked in mystery. For centuries, it was taken for granted. Children learned language by a process of imitation, reward, and habit. But in the 1950s, a new theory proposed a language acquisition device unique to humans, wired into the brain. It's now 25 years since linguists and psychologists were shaken into reappraising the state of their art by Noam Chomsky.
One of the faculties of the human mind is the faculty of language learning. I would think we must agree with Descartes that this is probably, no doubt, I think, a species-specific characteristic, unique property of the human mind. And in trying to determine what the faculty of language might be, we look at the very difficult empirical problem of explaining how it is that a young child with very limited information available to him acquires a system of language and knowledge of language that enables him to produce and understand this vast number of new sentences.
We have to be grateful to Chomsky for having introduced the idea that shook us out of a kind of dogmatic slumber in which we were caught with St. Augustine's model of imitation learning. But what was curious about the tremendous breakthrough of rethinking it is that when he proposed a language acquisition device, he did it, first of all, without any evidence, proposing it as an hypothesis that there were too few instances for the child to come up with so complicated a set of ideas as are contained in grammar. And to get away from all of the empiricist dogma that had gone before, he proposed that the language acquisition device could simply take as its input whatever was going in language, even degenerate input, semi-grammatical sentences, and this miraculous device, knowing the deep structure of the language, could then somehow bang it out and pick up what in effect were the rules of the language.
I think the people at MIT, or the Chomskyans, tend to believe that the language acquisition device simply springs into activation if one is exposed to language. And the rest of us have begun to think that you need something beyond exposure. You need interaction to acquire language.
We always have an interaction between the environment and the innate capacity. So the arguments between nativism and empiricism are really posed as polar opposites, when the issue is not so much is it innate or is it environmental, but the issue is how do these interact? What kinds of innate capacities does the child need in order to make use of what the world provides? If we pose a question this way, a lot of the heat of it is dissipated, and then the question becomes the hard scientific work of trying to specify just what built-in processes are necessary to account for this particular developmental history.
Where to begin? Investigators disagree. Evidence is accumulating for some innate basis for language acquisition. Could the baby be learning the characteristics of speech while still in the womb? Or is it with the first cry that language begins? Here at the Brigham and Women's Hospital in Boston, 4-day-old Debbie has her cries analyzed by Dr. Barry Lester.
Her cry is good and lusty. When she initially started crying, there was a period where she held her breath for a long time, which is how a painful kind of cry usually starts. But her cry has a good melody form, and it's a nice, robust cry. And what's also very nice about her is that she quiets by herself. She's very expressive. I mean, she has a lot of affect in her face, yet she's not out of control. She's able to pretty much calm herself.
Barry Lester monitors the cries of newborn babies for acoustic properties. His research integrates the behavior of the baby on the video screen with a computer system which plots respiratory rate, heart rate, and the analog cry signal. What does the sound of Debbie's cry tell us about later language development?
We look at adult speech. Adult speech has what are called prosodic qualities to it, meaning intonation and voice patterns and pitch patterns. It also has grammar and syntax. I mean, those are the two components of adult speech. Well, crying has only the prosodic components. Crying is changes in pitch and intonation and melody patterns.
Crying has at least two of the qualities of speech. It'll be 3 or 4 months before Debbie's vocal tract and larynx has developed sufficiently to make sophisticated speech sounds. But in these early weeks, there are significant developments in the discovery of new sounds. Peter Wolf.
This, quote, discovery of new sounds is done primarily when the baby is by itself, and particularly in the transition from being alert and quiet to beginning to cry. There is this fussy period, and it's there that we find the discovery of new kinds of sounds. And they then become a part of non-cry vocalizations when the baby is perfectly alert. And there, I think you see the beginning of experimental manipulations of sounds while they're perfectly content. And it is the discovery of different patterns of sound production that may be the linkage between crying and language. That does not mean that cry patterns are directly built into the language system, but it is the transition from cry to fussy to the discovery of new sounds that may be, at least at the physiological level, the tie with learning how to speak the language.
Hearing has as much to do with language learning as voicing. An infant's ear is fully formed early in development. Barry Lester tests Debbie's responses to the rattle. But what does she make of the stream of sounds around her? How will she distinguish speech from other sounds? In the Department of Engineering at Cambridge, efforts have been made to decode speech sounds and present them visually. The display gives us a clue to the complexity of every word and the task facing a baby. Frank Fallside explains.
The first group of sounds are the voice sounds. These include the vowels, ah, eh, oo, and so on, and sounds like and So these are shown a clear, solid trace. The second group of sounds are hissing sounds, fricative sounds, voice sounds with a lot of high frequency energy in them. Sounds like s, sh, f, and so on. These are shown in a different way in the trace. So, for example, s now comes up as a checkered pattern. If you now add these into words, clearly the different patterns show up during the word. So if we take a word like see, you see the unvoiced sound at the beginning and then the voice part at the end. We take another word, wash.
And there's a third element, silence.
Watch, where we have the voiced part, a gap, and then the unvoiced part at the end.
If that seems complex, listen to this. Elizabeth is 4 weeks old. She's fed the sound da every time she sucks. When she gets bored, her rate of sucking slows. It picks up again when the sound changes to ta. She's interested. The experiment was designed to test babies' responses to change in speech sounds. Its designer, Peter Imas.
These infants, very young infants, are extremely sensitive to the information that's in the speech signal, that is, to the acoustic parameters that are there. And the second thing it tells us, I believe, is that they have some very nice abilities to categorize speech. That is, to sort sounds into the kinds of categories that in a few months will come to have linguistic significance. What it tells us is that there's a strong biological component to the processing of speech and to the perception of speech. That is, our inheritance helps us understand speech, helps us to perceive speech. You get a start on the system. You know what categories are going to be important. You know how to sort the sounds into these categories.
Are babies born with the capacity to distinguish sounds? If they have this innate capacity, how is it used in this situation? Breastfeeding infants communicate with their mothers through little noises and gestures. Mothers invariably speak back, and a conversation or exchange develops. Feeding provides a context for language learning. Sucking, like speech, is highly organized. These mothers and babies are taking part in a research study led by Harry McGurk.
The baby sucks, paws